So as you can see, this is here because some of you may need help with trig. Well, this is not a trigonometry course. You certainly are required to use it to kind of know some of the basic trig functions. So let me just boil it down to the things that you need to know for this class. In most of the situations, you're going to be looking at some form of a right triangle in terms of vectors, meaning we could be looking at a vector like this, and you add another vector to it like this, so that the resultant vector looks like that. Well, what trigonometry allows us to do is use the proportionality between an angle such as theta and the sides of the triangle that are near it. So here's an example. We have a big triangle. We're going to also add some little vector arrow notation here. We know this as a right triangle, unless you're being super picky. I understand my drawing's not perfect. But we're going to denote our angle here as angle theta. That is T-H-E-T-A, theta. It's a Greek letter. But basically, if you look at theta, and let's imagine that you backed yourself into this room. You're in this funky three-sided room. And you kind of snuggled your way back into this corner so that you're looking straight across the room at this wall. With respect to you, where you are theta, this is the opposite wall. Now, the one that is directly next to you, well, I know that there are two next to you. I'll explain there's a difference. But the one that's directly next to you here, we call adjacent. So that is the adjacent wall to you. Now, why isn't this one up here adjacent? Well, in geometry, you guys learned that this third side of a triangle right here, this special one up here, is longer than normal. So although it might be an adjacent wall, it is particularly named the hypotenuse. So, what trigonometry does is relate the lengths of these sides, the length of the opposite side, or the length of the adjacent side and hypotenuse, with what happens when you increase or decrease theta. So, what trig functions are, and there are three primary trigonometric functions, what they are proportionality constants, or proportionality functions. So let's move forward from this. Let's kind of redraw that triangle so it's a little bit smaller. There is our hypotenuse. Here is the adjacent side, and here is the opposite side, all to our angle theta. Now, the common trig functions are as follows. There's sine, cosine, and tangent. And there's this little device, mnemonic device, I suppose, that people have used for a long time, and it was SOHCAHTOA. I know some math teachers don't like that, and I would argue that it's inappropriate in some degree because it makes it appear as though things are being multiplied. I'll explain in a second. But what it is just to remember that so, the O and the H go with the S, meaning sine somehow belongs to the opposite in hypotenuse, cosine with the adjacent in hypotenuse, and tangent the opposite and adjacent. So this is what it's talking about. If you use the sine function, it is referring to the fact that if you took the sine of angle theta, it is going to be equal to whatever the result of dividing the opposite side length by the hypotenuse side length. So, for instance, if the opposite side length was 2 and the hypotenuse was 4, then you'd have a sine theta equals 0.5. Okay? Now, moving on, if you had cosine, its cosine of angle theta is equal to the adjacent side divided by the hypotenuse. So, cosine of theta says that this, the adjacent side divided by the hypotenuse. And then finally, I bet you're catching on, tangent of theta is equal to the opposite side divided by the adjacent. Okay? So, how this helps you. For instance, if you did not know the opposite side here, you didn't know the opposite length, but you had angle theta, and you had your hypotenuse length, then you could multiply the sine of angle theta. So you punch in your angle, hit sine on your calculator, and multiply by the hypotenuse, you're going to get the length of side opposite. And that goes for any of these. Now what's particularly useful here is that if we take the same sort of scenario, so we have our hypotenuse, our adjacent side, and we plop in theta. This time we're going to give theta a value. What's particularly useful is if that value didn't exist, we can work backwards. So let's do an example where we know theta and we determine a side length. So for instance, let's say we know the adjacent side is 3 meters long. It could be any vector. See, this vector would be 3 meters in the east direction. And if we know that angle theta is 30 degrees and we are looking to solve for h, we don't know what it is, what we are going to do is think trig function. I am standing in corner theta, 3 is adjacent, I am looking for my hypotenuse, adjacent and hypotenuse belong to the ka portion, so the cosine of angle theta is going to be equal to the adjacent side over the hypotenuse. So you write in what you know. Cosine 30 is equal to the adjacent side, which we know is 3 meters, and we don't know our hypotenuse. So by looking at our calculator in degree mode, we see that the cosine of 30 degrees is 0.866. If that is equal to 3 meters divided by the side we don't know, we do a little bit of swapping here, algebra, and you are going to determine that h is equal to 3 meters divided by 0.866, and that becomes 3.46, so 3.5 meters. Okay, so that's one way to use this. So here's a different way. This time we see that, well, it's all in white, but you see that theta is actually unknown. But what you do see is, while we don't know the hypotenuse, there's nothing up there, we actually have two sides of this thing to find. We see that if you backed yourself into the corner of theta, looked across the room, your opposite wall has a value, and so too does your adjacent wall. So, what trig function do opposite and adjacent relate to? Well, that is tangent. So tan theta is equal to 4 divided by 6, or 4/6. So, if we were looking to actually get the angle measurement of angle theta, knowing that tan theta is actually equal to 0.667, what you have to do is do something called the inverse tangent. So you will say that theta will be equal to taking the tan inverse, which is a little -1, of 0.667. And the way that you get that is on your calculator. Typically you have a second button, and you'll hit second tan of, say, 0.667, and what will pop out will be the angle 33.7 degrees. So this is just another way to use those trig functions. A couple of important notes. You have to have an idea of the coordinate system that's being used, and this is going to go for nearly every situation in physics. You have to know where theta lives. For instance, if theta is now this angle up here, it's still a right triangle. However, the side opposite theta is now 6, and the side adjacent is 4. All of the principles still are the same. It's just that you need to know that theta has changed positions, so your perspective changed. I hope some of this helped. You'll certainly be employing quite a few of these principles this year, and have any questions, let me know. I'll see you in class.